Alright everybody, welcome to my video on prisms. We're going to talk all about prisms here in this video. Nothing else, just that. And basically what we're going to look at is how to find the surface area of them, how to find the volume, and that will basically take us through the video. So, let's begin. Prisms are going to be a shape, a 3D shape, that can have really many different types of shapes involved in it. The most important aspect of it, though, is that two of the sides are going to be exactly the same, and then the other four sides are going to all be rectangles that connect these two shapes, these two other shapes that are the same. So, could have a prism that had a triangle up here and a triangle down here. They would have to be the same triangle, and then sort of connecting them, we would have these rectangles going up and down the shape. It could be laying on its side, of course. We could have one that had a trapezoid at the end, and then rectangles connecting over the rest of it, and then basically it would be a 3D trapezoid with rectangles connecting on all the other sides. Those would both be prisms. This one over here would be called a triangular prism, and this one would be called a trapezoidal prism, because the shape that is the same on both of those ends is a trapezoid. Prisms are named for these shapes are called bases. The two that are the exact same and across from each other are called bases, and that's how we name our trapezoids. So ones with the rectangles at the end would be called rectangular prisms. We could have pentagonal prisms if they had pentagons at both ends with rectangles connecting them. So we've got a few different things. Now, to find the surface area, which again is the outside, all of the outside parts of the shape added together, the areas of them, what we're going to need to do is we are going to use a little bit of new terminology and variables here. If you ever see a capital B, that's going to stand for area of the base. So remember, area of the base means that we're not looking for just a side length at this point. We're looking for that entire area. This is where your area formulas are going to come back into play. Also remember that if you ever see the big P, that means that it's perimeter. We had that last chapter with our regular polygons. So when we're finding the surface area, we are going to first of all need the area of the base. So in our triangular example, that would be the area of this triangle. But notice that on the surface there are two of them. There's the one on the top and the one on the bottom. So we're going to need for the surface area 2 times the area of the base. That's always going to happen with these. And then we have a few rectangles that we still have to deal with. Remember that rectangle's area is base times height, or length times width, however you want to say it. In this rectangle that we have up here, the base is going to be one of the sides of the base of the rectangle is going to be the side of one of those triangles. But you'll notice that basically what ends up happening is we could just take the perimeter of that base shape, and we could sort of treat that as the width of the rectangle. We could sort of unfold this to make one giant rectangle that would have the perimeter as the width. The height of that rectangle would be the height of the prism. So to get the total area of all of these rectangles, all we have to do is add in the perimeter times the height. So our surface area equation ends up being 2 times the area of the base plus the perimeter of the base times the height. Just like that. Volume is a little bit easier. All we have to do is take the area of the base and then multiply by the height of the prism. Now keep in mind the height of the prism, let me draw it in blue in both of these shapes. In the triangular one, it's pretty obvious. It's going to be that. It's going up and down. The tricky thing to remember is that in the trapezoidal prism that I have drawn, the blue line I'm about to draw, that right there is h. The height of a prism is the distance between the two bases. So it's not always going to be up and down height. Sometimes it's just referring to the distance between the bases. So h could be sort of going side to side too. Just keep that in mind. Now, the net of this, and that's sort of a 2D rendering of unfolding the shape and what they kind of look like. Basically, what you're always going to end up with is you're always going to end up with, so like for the triangular one, you'll have the triangle, and you'll have a rectangle going off of it. And basically, you'll have two more rectangles, and off of one of those rectangles, you're going to have the other triangle. If we were to fold that up, we would get the net. For a rectangular one, you would see something slightly different. For rectangular one, so let's say that this was one of our bases, and the other base is going to have to look the same. You might see something. This is actually turning out to be more of a square prism. That's okay. You know, something like that. Basically, you need it so that you have an equal number of rectangles as the number of sides of your shape, and sort of one on each side, which makes that happen. But you can see how the area formula, or the surface area formula, kind of works when you look at the net. Perimeter times height is that rectangle, or that giant rectangle in the middle, and then your 2 times your base are the 2 that are off to the side. So let's see this play out in a few examples. Find the surface area and volume of this right prism. Right prism just means that we're only going to be looking at those. The prisms have right angles at all corners and such. So that's what makes it possible. And by at the corners, I mean sort of just down here at these edges down here, at that vertex. All right, so surface area of this one. Just to make life easier, I'm going to call this rectangle up here, which also means the one on the bottom, as my base, just to make life easier. So for surface area, we need 2 times the area of the base. Well, if I look at my dimensions for that rectangle up there, I can see that it's a 5 by 6 rectangle. So we're going to have 2 times 5 times 6. 5 times 6 is 30. So 2 times 30 plus, we need the perimeter times the height of this prism. Well, the perimeter is going to be this 5 and this 5, and this 6 and this 6, the perimeter of the base. So that's 5 plus 5 plus 6 plus 6, that's 22. And we have to multiply by the height of the prism, which in this case is 2. So that gives me 60 plus 44, which gives me 104 centimeters. Now notice that my unit is centimeters squared, because what we're dealing with here is area. We have area. We're looking at the surface of the shape, so we have centimeters squared. Finding the volume is going to be a little bit easier, usually is a little bit easier. All we're going to have to do is find the area of our base and multiply by the height. Well, the area of our base is, oops, not 3, jumping ahead, 5 times 6, and our height is 2. So 5 times 6 times 2, which gives us 60. The units on this are going to be centimeters cubed to the 3rd power, because there are 3 dimensions in our volume. So that's the surface area and volume for that shape. Time to scare you a little bit with a regular polygon example, but don't worry too much. It's not one of the harder versions where you need to use trig. This one just uses Pythagorean theorem. So Finding surface area. So again, we're going to need to find 2 times the area of the base plus the perimeter times the height. You'll notice here that the base is this regular pentagon, which means that the height is going to be this 9 feet right here, which is kind of nice. All right, so finding the area of one of these, again, let's find the area of this triangle here and then use that to find the area of the whole thing. We know that this is a length of 6. If I draw the apothem down and draw this here, we know that one of the full sides is 705, so if we take half of that, we'll know the length of this bottom segment, which is 3.525, and now we need our apothem. So we'll use Pythagorean theorem. 36, which is 6 squared, equals 3.525 squared, or plus b squared. 3.525 squared is about 12.42. 36 minus 12.42 is going to give us about 23.57 equals b squared. And we just need the square root of that. So b is about equal to 4.86. And that's our apothem. So now we can find the area of the regular polygon. Formula for that, again, is 1/2 apothem times perimeter. So in this case, that would be 1/2 4.86 times, the perimeter would be 7.05 times 5, 35.25. So, what we're going to do next is we are going to multiply those numbers together, and that would be 0.5 times 4.86 times 35.25 gives us 85.66 feet squared. So 85.66 would be the area of that pentagon. So now we can go back over here and we can fill in the first part of our surface area, which is 2.85, or 2 times 85.66, plus, we just figured out the perimeter, which is kind of nice for us, which was 35.25, and we need to multiply the height of the prism, which is 9. So now we're going to combine all this together. 2 times 85.66 plus 35.25 times 9. And we get 488.57, and this again is going to be feet squared since we're dealing with area. So that's that example. We only have to find the surface area on that one. Next, find the volume of the right trapezoidal prism. So we are going to need to know the base length, and we are going to need to, or the base area, I should say, because that's part of the volume equation, and we'll multiply then by the height of the prism. Height of the prism here is 5 centimeters. Might as well fill that in right now. And now we just need to find the area of the trapezoid. Base 1 is 14 centimeters. Base 2, we can see from the bottom, is 6 centimeters, and the height of the trapezoid is 3. So we're going to have 1/2 b1 plus b2, that's 14 plus 6, times the height of the trapezoid, which is 3. Gives us 1/2 of 20 times 3, which is 1/2 of 20 is 10, so that's 10 times 3, which is 30. So the area of the trapezoid is 30 centimeters squared. So 30 times 5, which was our height, gives us 150 centimeters cubed this time because we're dealing with volume. And that would be the volume of that trapezoidal prism. Last example, find the surface area and volume of a square prism that has a base edge length of 5 feet and a height of 12 feet. So base edge lengths means that it's a square where all of the sides are 5, and then we have a height of 9 going in that prism. Okay, so surface area. Let's do that first. Base area is going to be, well, let's write down the formula, 2b plus perimeter times the height. Area of the base is going to be 5 times 5, which is 25. 2 times 25 is 50. That's the area that we get from the bases. The perimeter of the square is going to be 20. 5 plus 5 plus 5 plus 5. And we're going to multiply that by the height. So 20 times 9 is 180, which gives us 230 feet squared. I should probably label this with feet, as it says too. There we go. So that's the surface area. Volume. Again, remember, we're going to need area of the base times the height of the prism. Area of the base, again, is 5 times 5, which is 25. Height of the prism is 9. 25 times 9 is 225 feet cubed. Cubed because it's area or volume. Volume, of course, is three-dimensional. So that's how much space you could put, or how much stuff you could put into that prism. All right, that's it for the examples on prisms. Hope you found this enlightening and educational. More videos on different 3D shapes coming up, but this was the introduction to that whole idea. So, see you in the next video.